Hey guys, how are you? So, pre-algebra group. Hope everybody's doing okay. Hope everybody's staying safe. So there's a thumbs up for staying safe. Hope everybody's doing well. And everybody is social distancing, taking that 6 feet. Guys, I hate to say it, but it looks like this is going to be the way we're going to be taking notes for a couple weeks anyhow. I miss every one of you. I miss seeing every one of you every day. And I would give anything in the world to be back in school right now. But unfortunately, it's not something we can control, and we're just going to have to make it work. So this is how we're going to be doing notes for the time being. I would strongly encourage you, as I'm doing these videos and I'm writing the notes out, you're at home taking notes in your notebook. And you're getting everything down to help you study for any quizzes and tests, because we're still going to have assignments. We're still going to keep moving on like we would if we were in school. So with that being said, let's get ready to go. We're going to start a new chapter. You guys should have done your Chapter 5 work already, that pre-chapter work. So now we have our first lesson, lesson 5-3. We're going to start at a good spot in the chapter, skip a couple lessons that we've already done, and go straight into 5-3. And this we're going to solve by substitution. That's our heading and our title. I'm going to be honest, guys, this is one of my favorite lessons that I had when I was your age, back when I was in school. I don't know, for some reason I just really liked it. I think it was because there's a concrete way of doing this, and if you follow the steps, it works on every problem. So let's get started. Number 1, I've got the problem x plus y equals 800. I have the other equation, 7.5x plus 13.5y equals 7,680. My goal in this is I want to know what x is, and I want to know what y is. I want to know what are these two variables and what do they stand for. Now, something plus something equals 800. That could be a number of things. It could be 400 for x, 400 for y. It could be 799 for x, and 1 for y. But it's a little harder to kind of guess and check with our second equation. We can do this mathematically. We can do it through substitution. Guys, when we substitute, we want to get one of our variables. It doesn't matter what equation, but I want to choose one variable and get it by itself. So it could be this variable. It could be this variable. It doesn't matter which one. I just need to get one of the variables on the equal side by itself. Notice how on our first equation here, x plus y equals 800. There's nothing with x. There's also nothing with y. Whenever you have equations like this, these are going to be the easiest to get the variable by itself, to get it as x equals or y equals. There's only one step here. So I'm going to do this equation and get one of these variables by itself. If I want to get x by itself, I can move the y to the other side of the equal sign. It's plus y, so I need to do the opposite, so I can subtract y. So I'm going to be left with x equals 800 minus y. And that is my new equation now. Now we're going to get into the part of substitution. I'm going to take my x and I'm going to substitute it in where I see x in the other equation. I'm going to substitute it everywhere I see an x. So if x equals 800 minus y, everywhere I see an x, I'm going to put 800 minus y. So in my second equation here, I have 7.5, and now I'm going to begin to fill in what x is equal to. And it's equal to 800 minus y. And then I'm going to continue writing the rest of the equation. Because I don't see another x, I don't have to write this 800 minus y anymore. So all I did is I substituted x for what x was equal to, and x was equal to 800 minus y. The reason we do this is we cannot solve this equation with two variables. I have an x, I have a y. I can solve this equation because there's only one variable. That one variable is y. I have eliminated the x and I have gotten rid of it by substitution. So now I can solve for y and I can figure out what y is equal to. Grab your calculators. So my first step is I'm going to distribute. So I'm going to distribute my 7.5 into my parentheses. So if we turn our calculators on, looks like I had a couple things in there. I can do 7.5 times 800. That equals 6,000. 7.5 times negative y. So I'm going to have negative 7.5 y. And then because I don't have any parentheses anymore, I'm going to carry everything else straight down. When we get to this step here, every one of you in class, I'm confident, should know what to do. I need to combine like terms. Notice my negative 7.5y and my 13.5y, these two are like terms because they both have a y. So we can go back to the calculator. Negative 7.5 plus 13.5. Guys, only type in what you see. Don't add any extra signs. Notice I've got a negative and a positive. So when I type this back in, I should only have a negative and a positive. Hit enter, equals 6. So I have 6,000 plus 6y equals 7,680. It's like when I was little, whenever I was your age, and we're doing these, it's almost kind of like a funnel and an upside down Christmas tree. You should be kind of getting your way and should be getting smaller to the bottom. Now I'm trying to get y by itself because I want to know what y equals. So to do so, I need to move this 6,000 to the other side. So I'm going to subtract 6,000 because it's positive. So minus 6,000 on both sides. And I'm left with 6y equals, bring our calculators over, 7,680 minus 6,000 equals 1,680. In your final step, we turn this into now just one more step. To get y by itself, I need to divide by 6. Looks like we're getting a little bit into your next problem. So when I divide, y is equal to, bring our calculator back, 1680 divided by 6, 280. So y is equal to 280. Now remember back whenever we were talking about this problem to begin with, I wanted to find out what both x and y equals. So guys, whenever you're solving these problems, you should have two answers. So I'm going to kind of add this up here and with a star. Anytime I'm solving this substitution, I should have two, and this is one of the trickiest words I've always had to spell, two answers. So y is equal to 280. I need to find what x equals. So I'm going to take my 280, and now everywhere I see a y, I'm going to substitute y for 280 because y equals 280. You should be asking yourself, in these three equations, which one is it going to be the easiest to solve? And there should already be a red flag with this middle equation. There's a lot of work, guys, in this middle equation if I were to put 280 in for y, because I would have to multiply by 13.5, move it to the other side, divide by 7.5. That's a lot more work than if I were to put 280 into this last equation. If I put 280 into the last equation, I just have to do one step. I just have to do 800 minus 280, and that will tell me what x is equal to. So be smart about what equation you're plugging your y equals into. This first equation, guys, is not a bad equation to use either. If you plug 280 in, you want to get x by itself. You subtract 280, you're really doing the exact same thing that we're doing here on the last equation. So I would choose the first or the third equation to plug my y equals into. So x equals 800. I'm going to use the last equation, minus 280. Bring your calculators over because I want to make sure I get this problem correct. 800 minus 280 is equal to 520. So x equals 520. And those are my two answers for this problem. So there you go. There's substitution. Let's move to another problem. Let's see how we do on this one. Number 2. Again, I have x plus y equals 50. And I also have 2x plus 5y equals 160. Just like what I did on number 1, I want to get a variable by itself to begin. So notice we got x equals to start the problem before we started doing all this solving. I want to get it where it's a variable equals something before I start. Just like up on number 1. Notice how this top equation was a lot easier because I only had one step. I just had to move a variable to the other side. Same thing on number 2. This top equation, there's nothing with x, there's nothing with y. This equation is going to be a lot easier to get a variable by itself. Now in the first equation, I got it where it was x equals. I don't want you to think you always have to get x equals. So on this one, let's get it to where it's y equals. Regardless of how you do this, if you do x equals or y equals, you should still get the same answer. To get it where it's y equals in my first equation, I'm going to take x, subtract it to the other side because it's positive. So I'm left with y equals 50 minus x. So now I have y equals, I have a variable equals something. I can now begin to substitute just like what I did up top here. So everywhere I see a y, I'm going to plug in 50 minus x. So number 2, 2x plus 5. I came to a y, so now I'm going to plug in 50 minus x. Finish writing your equation, equals 160. You have already probably noticed this, guys, from number 1 and number 2. Whatever equation you change, you're going to plug this in to the one that you left alone. So notice on number 1, we left this middle equation alone when we started the problem. So we plugged x into that middle equation. Same thing on number 2. I changed the first equation, left the second one alone, so I plugged this into the one I left alone. I plugged it into the second equation. Let's continue solving this one. So I have 2x, I have some parentheses, so I need to distribute my 5 into everything. So 5 times 50, for those of you, let's use our calculators, 250. 5 times negative x minus 5x is equal to 160. Just like what we did on number 1, guys, again, this is why I like these problems so much, because there's a lot of repetition with them. We've distributed. Now we need to combine like terms. So 2x minus 5x, that is equal to negative 3x plus 250 equals 160. After we combine like terms, again, just like what we did on the last problem, I need to get x by itself. So we're going to subtract 250. When we subtract, so on both sides, I have negative 3x equals, for those of you, it's okay if you have to use your calculator, 160 minus 250, we get negative 90. And then my final step, get x by itself, divide both sides by -3. When I divide, x equals -90, divided by -3, 30. So x is equal to 30. Just like on number 1, I need 2 answers. I've only got 1, so I want to make sure I get all my possible points on this problem. I'm going to take x equals 30, and I'm going to plug it back in one of these equations. Again, I would not choose the second equation. It's going to take you longer and a lot more time. Again, first or third equation can be a lot easier. Let's plug it into the last equation. Y equals 50 minus, came across an x, so let's substitute. 50 minus 30, y is equal to 20. There we go. I've got an x, I've got a y, x equals 30, y equals 20. Just so you can kind of see how this works, I plugged the x into this last equation. What if I did plug it into the middle one? Even though it's going to create more work, I still want you to see how you're still going to get the same answer. So if I were to plug it into the middle equation, I have 2 times 30. You do not need to write this down. Just watch. 2 times 30 is equal to 5y equals 160. I need to multiply first. So 60 plus 5y equals 160. Move 60 to the other side. I subtract it. So I have 5y is equal to 100. My last step, I divide by 5. And hey, what do you know? Y equals 20. So I got the same answer, but notice there's a lot more steps the second go around. Make it easy on yourself. Choose an equation that's simpler, and it'll move a lot quicker. Also, guys, what I will say is there's a lot less room for error on this equation than there is on this equation. All right, let's try number 3. This may not be a bad problem at this time to maybe pause the video, try it on your own, and then once you finish, you can press play, and we can see how you did, and kind of compare your answers. Let's move into number 3. We have y equals 0.8x plus 0.5. And then I also have the second equation, 3x plus 4y equals 5. Guys, this is what I call a gimme. I had a college professor, he would write on the board whenever we solved problems in class for easy problems, he'd write P-O-C. And when somebody raised their hand and asked him one day, he goes, what's that mean when you write down the problem? He goes, piece of cake. This is what I call a piece of cake problem. It's a lot easier than what we had on number 1 and 2. And it's easier because we've already got a variable that's equal to the equation. Y is already equal to something. It's already isolated. We don't have to do the extra work that we did on 1 and 2. I can go ahead and already substitute it in. Whenever you're given gifts like these, take them and say thank you. So, whenever we're given this problem, let's plug it in. So, if I plug y into everywhere I see a y, I'm going to get 3x plus 4, and then I begin to substitute. On every one of these problems, guys, when I have substituted and I've taken this and I've plugged it in, notice I've been putting parentheses. You need to be doing the same. This is showing 4 is multiplied by y. So 4 is being multiplied by all of y, not just part of it. So 4 times 0.8x plus 0.5. And that is equal to 5. Now I can distribute, so I'm going to plug 4 into everything. So if I carry this down, I have 3x plus, bring your calculator over if you need it, 4 times 0.8 is equal to 3.2 x, 4 times 0.5 plus 2, whoops, 4 times 0.5 is equal to 2. Then that's equal to 5. And again, we're seeing this repetition come up. I've distributed. Now I need to combine like terms. So 3 plus 3.2x is equal to 6.2x plus 2 is equal to 5. I'm running out of room, so I'm going to go ahead and move this up. Not quite like working on a whiteboard, that's for sure. So 6.2x plus 2 is equal to 5. Alright, I need to now get x by itself, just like we've been doing all this whole entire lesson. So I'm going to take my 2 and subtract it. Always do the step with the variable last. So I'm going to do the 6.2 last. So I have 6.2x is equal to 3. Last step, divide by 6.2. And when I divide, 3 divided by 6.2, we get this ugly decimal. Let's go ahead and let's just round. We'll just go ahead and round that decimal. Let's say to the hundredths. Whenever we get any problems like these guys, let's go ahead and let's just keep it consistent and let's just round things to the hundredths. So on this problem, it's going to end up being 4.8. Or excuse me, 0.48. So x is equal to 0.48. Notice whenever we type this in, the hundredths is your second decimal spot. The 3 that's behind it makes it stay the same, does not round up, so therefore 0.48. Take my x, plug it back in, and let's find what y is. Now in this problem, both of our equations have some meat to them. They've got some pieces here. The first equation has a lot less to kind of work with. Because I plugged this 0.48 into x, I solved the right side and it's already equal to y. So I can plug that in. Y is equal to 0.8 times 0.48 plus 0.5. I go through and I simplify. Y is equal to 0.8 times 0.48. When you multiply, you get 0.384 plus 0.5. I go through and I add. I get 0.884. So my y is equal to and again we'll round to the hundredths, 0.88. So I have an x, and I also have a y. A little more of a difficult problem with all the decimals. However, we can still do it. Again, take these gifts. Whenever your problem starts out as a variable is equal to something, use it. It's only there to help. Alright, 3 more problems and we'll be done. These next 2 guys, these are special problems. And I made sure that I put this in our notes, and I think it's a good idea you put some stars next to them in your notebook as well. On this type of problem, I have y equals 14x, and I have y equals 14x plus 7.5. Again, we're working with substitution. Notice how both of these problems are already set up as y equals. So I'm good there. I don't need to get a variable by itself because I already have 2 of them. I'm going to substitute this first equation, substitute that y into the second one. It doesn't matter which one you do or how you substitute as long as you plug one of them in for the other. But when I do so, it looks like 14x equals 14x plus 7.5. I need to combine like terms next. Notice my x's on different sides of the equal sign. I need to get them on the same side. So I'm going to subtract 14x on both sides and move the right side to the left. When I do so, these cancel, and hey, 14 minus 14, that's 0. So I'm left with 0 is equal to 7.5. That's a red flag because I know 0 is not equal to 7.5. So this would be a no solution. So guys, anytime whenever you're substituting and your variable disappears just like it did here, it's going to become a no solution. Only when your variables disappear. So notice 14 minus 14, that equals 0, those disappear. Those are not equal to one another. So that would be a no solution. That is possible to get that answer. Alright, two more. Number 5. This one's a little, we got some pieces here on this one. I've got negative 2y minus x equals negative 84.91. My second equation is 3x plus 6y equals 254.73. Wow, the book did not help us out on this one, guys. They gave us kind of a tough question here. But that's okay, we can do it. I want to get a variable by itself. Notice all my variables here, they're not by themselves. They've all kind of got something going on with them. So let's do our best to get one of them alone. I'm going to try and get this x alone because notice there's nothing with it except for this negative sign. So let's work on getting it by itself. So I need to move this negative 2y to the other side. To do that, I need to add it because it's a negative. So I have negative x equals negative 84.91, and then I'm adding the 2y, so plus 2y. I'm not finished, believe it or not. I need to get rid of this negative sign. You cannot have a negative variable. Let's turn it into a positive. And here's a cool trick whenever you do such. If I turn this x into a positive x, all my other signs flip. So this becomes a positive 84.91, and this then becomes a negative 2y. This happens because we're really just dividing by negative 1. That's kind of a cool trick when you're getting rid of a negative with a variable. You can just change the signs on the other side of the equal sign. Alright, so this, and I'm going to star them because we've got a couple equations up here. Those are the two equations that we're working with. Guys, I can't stress enough how important it is to keep your work organized and neat when we're doing substitution. I can now substitute in for x. So let's substitute in. I have 3, plug in for x, 84.91 minus 2y plus 6y equals 254.73. I distribute. So let's get our calculator out because that's a multiplication problem I'm not too familiar with. Let's do 3 times 84.91. I get 254.73. 3 times negative 6y, or excuse me, 3 times negative 2y is negative 6y. I'm going to finish writing the rest of this, so plus 6y equals 254.73. Now I combine my terms. So I have 254.73, negative 6 plus 6. Well, that's 0. So those cancel. So this is equal to 254.73. Guys, this is another special case. So notice 4 and 5, they followed suit. Hopefully you put a star next to it, just like I did in my notes up top here. These two are special. Notice 254.73 is equal to 254.73. That's true. That's going to work every single time. Anytime you get a number is equal to that same number, this means it is an infinite amount of solutions for this equation. So my answer is just infinite amount of solutions. And there you go. So infinite amount of solutions. That's my answer there. And we could just leave that as infinite if you would like. Very good. Guys, last problem, number 6. And this is going to be one that I strongly encourage you to pause the video again, kind of complete it on your own, and see what you get. All right. Hopefully you paused it and you're resuming it right now. We can work it out and you can check your answer and see how you did. This is, again, one of those. There goes my projector. 1 second, guys. All right. This is another one that my college professor would put on the board. POC, piece of cake. Y equals, my variable's already by itself. So, my variable's by itself, I can already go ahead and begin to substitute. So everywhere I see a y, I'm going to plug in what it equals. So x minus, even though there's no number out front of my y, still want to do my parentheses. So negative half x plus 4. And that equals 8. Go through. What's really out in front of my parentheses here? It's a negative 1. I am going to distribute a negative 1 into my parentheses. So x, negative 1 times a half is negative half x. Negative 1 times 4 is negative 4 equals 8. Now, combine like terms. So I have 1x minus 0.5. Notice, there's no additional signs that I put in my calculator. Guys, I can't stress that enough. Some of us were kind of struggling with that back before spring break. Make sure your calculators match sign-wise with your problems. So I have 0.5x minus 4 equals 8. Get x by itself. I need to add 4 on both sides. So I have 0.5x equals 12. And your final step, divide by 0.5. So 12 divided by 0.5, x is equal to 24. So there is one of my solutions for this problem. Last step, take your x, plug it in. So when I plug it in, I have 24 minus y equals 8. Again, doesn't matter which one you plug it into. We've been plugging into the first one a lot today, so I'm going to try doing the second one. I need to get y by itself, so I'm going to subtract 24. I have negative y equals 8 minus 24, which is negative 16. Last step, told you guys earlier, variables cannot be negative, so I need to get rid of that. So whenever we do so, the signs just switch. So x equals 24, y equals positive 16. Hopefully you got that one right. Hopefully you checked it. I bet every single one of you in class did, because you guys are smart kids. Real quick, last thing, because this is our final problem. Some of you in class, I noticed, you like to go ahead and check your work. When you get your x and you get your y, and you want to check your work, take your x, take your y, plug them in to one of your equations at the same time, and they should make your equation true. I'm going to take this second equation down here. This x minus y equals 8. What was x? X was 24. What was y? Y was 16. So 24 minus 16 equals 8. 24 minus 16 is 8. So 8 equals 8. So this worked out. So I know my x and my y have to be true. Do not confuse this part of 8 equals 8 to this part up here with the infinite amount of solutions. The infinite part was when we went through and solved and the 2 equaled and your variable canceled out. The 8 equals 8 on the bottom was once we had solved for x and y and plugged them back in. You don't have to do this in all your problems, but it's a way of going back and checking. If you were to plug these 2 back in, and let's say, for example, you got 7. 7 does not equal 8, so one of your x or y's would have been wrong, or maybe even both of them. So again, just a way of checking your work. Guys, I hope you enjoyed the video. I know it was a little lengthy. We're going to focus some more on this lesson the rest of the week. Let me know what you thought. This was our first video like this. Shoot me an email if you feel like. Let me know your thoughts about it. If you liked it, if there's something you wish was different. And we can kind of go from there with it. Guys, again, I miss every one of you dearly. I hope you're all doing really well right now. And with that being said, have a good rest of the day. Thanks, guys.